Hi guys, just want to show you what's going on here. I have my board powered on. Ignore the dead 5-volt LED. I killed it. The modulator's off, signal generator's off, the bridge is disconnected. That's the newly etched bridge that I made. I made 2 of them, but I'm only using 1 to test, and in efforts to reduce the leakage inductance, I've wired the secondaries kind of looped underneath there, curved underneath there. I could probably shorten them a little bit more, but I don't think that that's going to make the biggest difference. But that's not the primary problem here. I'm going to be monitoring the voltage off the regulator, and I have the blue trace from the oscilloscope hooked up to the inverting output of the drivers there. So I'm going to turn on the signal generator and turn on the modulator. I'll show you what's on my scope here with the GDT disconnected. So we have good looking waveforms. The blue is, again, that's the output of the drivers. The yellow is directly from the interrupter, and as you can see, the pulse width is 106 microseconds. Pulse repetition frequency is 110 hertz. So yeah, everything looks good there. Now I'm going to turn the modulator off, and now I'm going to connect the GGT up. There we go. I don't know, you probably couldn't hear it from this video, but I could hear one of the diodes start clamping as soon as I hooked up the other primary there. And I'll show you now what I'm getting on the oscilloscope on the blue trace. And again, the modulator is off, only the signal generator is on, 100 kilohertz square wave there. Oops. So let me trigger this here. Show you this nasty looking waveform. So you can see there's some overshoot, most likely due to the leakage inductance. I've tried adding some series resistance, increasing that, and all it did was make the rise times even longer, and they're already a little too long. As you can see, that little, it kind of like curves off. It doesn't go straight up and then spike, it just kind of curves off, so that's already a problem. So now what I'm going to do is turn on the modulator, and you can probably already hear the core. It's kind of loud. So yeah, as long as there is a signal present in the feedback circuit, it runs just fine. The 15-volt regulator, it gets kind of hot, but not as hot as it would be, as it was when I was having other problems, and you'll see that the voltage is just fine. So yeah, I mean, I can run this for a while, and there's not going to be a single problem. So what I'm going to do now to show you the actual issue that I'm having is I'm going to show you what happens when only the modulator is on. First, I'm going to disconnect this, turn the modulator off, turn the signal generator off, reset my oscilloscope here. Okay, I'm going to turn the modulator back on. Okay, and that's what we got. Okay. So let's see if I can get you to hear this. Okay, so yeah, you heard it the normal frequency for like a split second, and then it just kind of droned out. Now when I do that again, you'll see that you'll notice from the LED indicator that the 15 volt regulator is just, something's going on. Watch the voltage. Just wants to drop. And this yellow primary here is, that one's connected in series with this tantalum cap here, and it gets really hot as well as the regulator here. And I'll show you what I get on the oscilloscope when I also connect it. Okay. I rebuilt the interrupter because, you know, I don't know, I was just kind of running out of options and decided to rebuild it just in case. And actually this interrupter is a lot nicer. I got the burst mode to work now. So yeah, I mean, I don't know. I did this board using the artwork from Eastern Voltage Resources, and it's, you know, the same artwork. I just recopied it in Eagle and made it that way. Everything is connected the way it's supposed to be. Yeah, so I really don't know what's causing that. My next plan is to use this board here that I recently etched, and as you can tell, you might be able to tell that it's the power supply layout as well as the gate drive layout. I copied very closely to the artwork that's also available from Eastern Voltage Resources. Just to show you real quick, give you a little overview of what we have here. We have the power supply inputs here. Here and here we have our two electrolytic capacitors. Voltage regulators go here, along with the coupling and decoupling capacitors. And then, let's see, this is our 15 volt rail that goes down here. And then we have, if I remember correctly, these will be two tantalum capacitors. Our gate drivers with some capacitors in between and some more capacitors up here. And our outputs. And then I tried to keep the primary signal circuitry away from the gate drive, so I put it up here. We have, off the top of my head I forget which I made which, but one of these is the primary overcurrent detection, and the other one is the primary current feedback. And then here we have those 8 little circles are for the fiber optic in. So, you know, all of our signals I try to keep coming in up here, away from here, and our ICs, that left me with lots of room in the middle here for the ICs. And I use lots of vias to carry the signals. You can see these little vias here. And again, off the top of my head, I forget which IC is which. I'm pretty sure that this is the 74HC74, this is the 74HC08, and this is the 74HC14. Show you the flip side here. So yeah, this is the 74HC14 now that I flipped it over, and out of pin 4 goes right to the ends of the gate drivers. And then what word was it? Oh yeah, and for then the enable for the gate drivers is this rail right here, and there's a via right there because I had it right underneath, and it comes from pin 6 of the 74HC74. So yeah, I mean, I don't really know. This is like other than this board, which was actually the first board I etched, and it was pretty much just a trial board. I didn't even plan on using it, but I ended up using it because it turned out that the alignment was like superbly accurate, and I was surprised that I did it that well, so I decided to solder everything up and give it a try. And as you can tell, it's not really working. So this is my second design, mostly pretty much all inspired by the artwork from Eastern Voltage Research, with a little bit modification of this area up here. So yeah, I know that my videotaping skills are pretty bad, but there is no manual focus on this, it's all autofocus, so I try my best to get a good shot. But yeah, I mean, I guess just let me know what you think of this board layout. I can't really get a close-up because then it's just going to go all out of focus. So this is about the best shot I can give you. I can also post files if you want. Yeah, I mean, I thought it was a pretty solid layout. I tried to keep a nice good ground plane. I try to keep most of the power rails, which is right here and up here, and then the 5-volt power rails is right here with I think, and right here going to this IC. I try to keep that pretty much away from the traces that are carrying signals around here. And you know, like I said before, I try to keep the primary signals that come in up here in the corner away from everything else. So I don't know what you guys think of that layout, but I hope that this will work. So yeah, thanks for watching.